So good morning and welcome to one of our foundational webinars. My name is David Orr. I'm the director here with the Corner Local Roads program. We're your New York State LTAP Center. And today we're going to be talking about the stuff that's the brown stuff under your road. Whether you got a paved road, concrete road, brick road, or gravel road like you see in the picture over in the town of Preble. The gravel and the base materials are pretty important. We're going to be using poles, and I'll talk a little bit more about them in just a minute. But just as a reminder, for those of you who haven't been on, this also might be useful. If you have any audio issues, please go down to the lower left. You're going to want to open up your chat pod. In the chat pod, we will be putting a link to the polls. You have to type it in, and a link to a handout that we've got. It's got some good resources on it, and I'll talk about a little bit those resources as they go through the course of the day. And then you're going to want to open up your Q&A pod. That's a place where you can put in some questions as we go along. I really like to see your questions, so don't feel bad about asking any question. If it's a technical question, Jody and Amanda, who are sitting in the background, will take care of it. If it's something dealing with the webinar, I'll take care of it. I may ask you to raise your hand a couple of times, and we'll go from there. Now, this particular webinar is worth one professional development hour here in New York State. Only the person who's registered can get the credit, because we have to have documentation for the education department. But it does get counted as a course because it's live, so that's a good thing. If you're not from New York and you need a PDH for engineering credit, check with your LTAP center in that state. They'll be able to tell you what the rules are and how you get the credit if you need it. Okay, so let's start with a little bit of a welcome, find out who you are. We're going to do that with a series of polls. And again, it's www.pollev.com/DavidOrrPE. Okay, so I'm find out where you're from, who you work for, stuff like that. Okay, and again, if you can't do the polls, some reason you can't access it, you could put it into the Q&A and I can just add that into the pool. So let's start with, who do you work for? Okay, and okay, we've got people already adding in. So we got folks for towns and counties, cities and villages. We got a few folks who are ready for the weekend, though it looks like it might rain this weekend. It was a beautiful one last weekend. And of course, I wasn't feeling great and missed the Aurora Borealis that you can see from Ithaca, but well, that's my own fault. But okay, cool. Good variety of folks. Okay, so quite a variety. That's cool. I like it. Okay. What's your job? Are you an administrator? Are you the commissioner or highway superintendent? Are you an engineer? Are you part of a field crew? Are you the supervisor of that field crew? Are you a board member, elected kind of person? Or are you none of the above? And I'm guessing, yep. Typically see a lot of engineers when we give out the engineering credits, but we have a supervisor. We have a none of the above. If you do a none of the above, pop it into the Q&A what that means. And I do see someone put in there that they're in the field crew in the Q&A as well. So, okay. Okay, so mostly engineers, but a spattering of other folks. That's good to know too. Cool. And then where are you from? And there is some differences with gravel. Might be nice to know where you're from here in New York State, or if you're not from New York, you can put your little dot on the map. Ah, we have somebody from Southern Vermont, for instance. That's good. Okay, looks like it's almost Brattleboro. Okay, and again, if you can't get access to that, you can type it in as someone did. They put in, they're from Long Island. Okay. Which is a sandy material. Oh, we're missing our friend from the middle of the lake. I guess with gravel, it's probably not as critically a lot of gravel in the middle of Lake Ontario. That's good variety. A lot of downstate. Okay. Now, this, of course, is our summer webinar series. We do these webinars when we're not doing other active training. We have 3 more for the summer. This Thursday, we're doing a special communications one. It was scheduled for last week, but the instructor got sick. So we moved it to this week, Thursday, from 9 to 10, just like this one. Next week, we're talking about the MUTCD signs in general, but there is a new MUTCD out. So if you've got a sign question or a traffic control question, we're going to talk a little bit about the updates to the MUTCD that are out and some schedules that we've got for updating the traffic sign handbook. So that might be useful, and that's worth the PDH. And then we'll take a couple of weeks off, 1 week when the county superintendents meet up in Niagara Falls, Labor Day week, and then we'll be doing our last webinar on snow and ice, an overview of it on September 10th. Okay, and that'll end our summer series. So let's start with, why do we build roads and streets? Now, I've asked this question in some of our other webinars, but it's a An important one when it comes to dealing with gravel and base materials. So let's see what you guys think. Transporting goods and services, yeah, moving things from point A to point B. Yeah, that's important. We got to travel, yeah. Okay. Yeah, so most of you putting down travel, that's a pretty good reason. We're going to move people and materials, and that's really the big thing. We're moving people from point A to point B. We may be helping them in emergency issues and public safety issues. We may be dealing with getting them to school or to church or a community event. We might need to be getting to business and work. And whether they're moving by vehicle, whether they're moving by bicycle, pedestrian, they're moving. And it's an economic driver that we sometimes forget about. So these are all good reasons that we've got. So very good. So if you look at it, these are why we build the roads and streets. But to do that, we have to look at the traffic that's on the road, both the volume and how heavy it is, the structure of the road to handle that traffic, and then the geometry, which we won't talk about much today, but it is something we have to think about. And there is actually a geometry to the structure as well. So let's talk a little bit about that traffic and structure. When we developed our local roads done right class, and we still call it Basics of a Good Road, one of the people who taught for us like to say, you need to build the road to handle the loads. And so whatever the loads are and the weather conditions, you need to change the structure to deal with that traffic. So this is from Yellowstone National Park, and probably not a traffic consideration we have to worry about too much, but yeah, they have bison who go down the road and they're pretty heavy on their hooves. So something you have to actually think about. Now, another colleague sent me some photographs. He took a trip to Russia, and this is the main road from Moscow to Siberia. It's an unpaved roadway. And so if you get an unpaved roadway and you have problems in the spring with spring thaw, you can have yourself a really bad day if you don't have a good structure. So we really want to think about the fact that roads have a structure. We talk about bridges all the time, but roads have a structure as well. And so there's a geometry to that structure. There's the surface, there's the base. Sometimes there's an extra layer called a subbase, which is usually unbound, and then there'll be a subgrade. And the subgrade is just a fancy term for the native material we build the roads on. Everybody likes to figure out why they get that name. Well, it had to do with the grading of the land. It was the subgrade after you stripped off the organics and anything you didn't want to have as part of your road structure. So keep that in mind as we move forward. Okay. Now, when it comes to vehicle loads, those loads cause the pavement to have a force on it. Okay. And one of the goals of a good pavement is to spread that load out. And if we do a good job of that, we reduce the amount of deflection that we see. And it's the reduction of the deflection that makes the road last longer. Now, you've seen this video before, if you've been to many of our webinars that deal with the geometry and structure of the roadway. But watch carefully the two green dots as these fully loaded trucks go by on a test track out in the western United States, built by the U.S. Forest Service. And you can see the pavement actually move under the vehicle load. And that movement is caused because, of course, the underlying layers are saturated. You can see the water that's just sitting there. Now, this particular road was designed to fail, and it was part of a research project. So the fact that in the 81 passes of these trucks, it looks like this, well, that's actually good from a research standpoint, not good from our roadway standpoint. So something we need to keep in mind as we're moving forward. How do we build a road to handle the loads? And where is the structure? Okay. Now, if you're on a state system, you're going to have a different structure because you've got typically more traffic. Some people might say arterial or collector, depending on how you define it. But again, if you got more traffic, you're going to have a thicker roadway. So this is a state highway. And in this particular case, they've got 3 layers over the subgrade. They've got a surface layer. They've got a base layer, which is actually asphalt. When the state talks about base, they are talking about asphalt here in New York. And then they have a gravel layer below that. Okay. So where's most of the work being done? Where's most of the structure in terms of resisting that bending forces? It's in the asphalt bound layers. Okay. So turns out the state is going to actually have less need for really good gravel because they're doing most of the work with the asphalt layers. But there's still some important value to having good quality gravel underneath. And yeah, you have to have some drainage in there, and the state does put in a drainage layer. It's an open layer, it's an open graded layer that actually does drainage as well as part of their structure. Now, if we look at a county road is typically just an asphalt layer, might be a couple of them, but it's an asphalt surface. And then below that is going to be a base that's usually unbound, a gravel layer, a few inches thick. Again, it'll vary. I'm going to talk to you and ask you some questions about how thick the roads are in your community or that you've worked with in just a little bit. But again, where's most of the structural work being done? Well, if you look at it, it's a blend. In this case, there's enough asphalt with that 3, 4 to 6 inches that it does some of the work, but the gravel underneath does some of the work as well. And of course, the quality of the drainage makes a huge difference as well. And then finally, let's look at a chip sealed roadway. Now, if you look at a chip sealed roadway, it's gravel with a layer on top of asphalt emulsion these days with stone. Is the asphalt emulsion doing any of the structural work? No. Now, all the structure is being taken care of by the gravel. The surface layer is really just a driving surface. We actually call them wearing courses, in fact, for that reason, because it's really just a membrane. It's like the paint on your house. It's protecting that gravel, but you could have the right gravel underneath, and we'll talk about why here in a little bit. Now, how many of you have or deal with gravel roads? No surface on top at all. Raise your hand. Go down and find your hand down the bottom of the screen. Raise your hand if you're dealing with gravel roads. Okay, I got a couple of you. Okay, just a couple of you. There we got a few of you. Okay. So if you have gravel roads, obviously in the case of a gravel road, the gravel is doing all of the work. And it turns out you need a slightly different gravel on a gravel road than you do on a paved road. And that's very important for the long-term structure of the roadway itself. Because remember, there is a structure in the roadway, okay? So let me ask you some questions about the roads you deal with. So first, if I just ask you, I want your first impression. If I said, what's the most common asphalt thickness, either in your jurisdiction or you deal with, what would you think? Most common asphalt thickness. Is it unpaved, less than 2 inches thick, 2 to 4 inches, 4 to 6, 6 to 8, greater than 8 inches? And I know you may have different thicknesses. In fact, you should have different thicknesses depending on the traffic and other factors. But what was your first impression? Okay. So majority of you, almost 2/3, said 2 to 4 inches. Relatively thin compared to the gravel layer underneath. Okay. Some of you are greater than 8 inches, and certainly if it's a state highway, it's almost always going to be greater than 8 inches. Okay. Now, at the same time, for a paved roadway, what is that most common gravel thickness that's underneath? Again, what's that first impression? What do you think? 0 to 6 inches, 6 to 12, 12 to 18, 18 to 24, or greater than 24 inches? Again, your first thought, and this is typically what we would see, most people put down 6 inches to a foot. Some put a little bit more. There's a bell curve, of course, involved with this. Okay, and again, somebody put a B in there in the poll in the Q&A. So 3/4 of you are putting down about 6 to 12 inches of gravel. Okay. And again, if you combine those two together, if we go back and look, if you think about 2 to 4 inches of asphalt and 6 to 12 inches of gravel, that's sort of like what we saw, and I mentioned the concept of the county or collector road, where the asphalt and the gravel are doing about equal work. Not exactly, and there's a lot more complexity that we're not going to get into today. But the concept is that some of the structure comes from the gravel, some of the structure comes from the asphalt, and it's fairly close in terms of their overall value. If you're dealing with a very thick asphalt layer over a very thin relative base, then the asphalt's doing most of the work. And you can probably get away with a little dirtier material, actually. If you've got just a thin chip seal, however, if you're one of the people in the 0 to 6 inch range for the less than 2 inch range, we don't have anybody on today, but if you're dealing with just chip seals, then the gravel's doing all the work. Okay. Now, again, for those of you who have unpaved roads, Do you have the same thicknesses? I'm going to clear this grid. Let me clear this. Hang on. I'm going to clear this. What would you say is the most common gravel thickness you've seen on unpaved roads? For those who have them, have worked on unpaved roads. 0 to 6, 6 to 12. Won't be a lot of you, I know. You guys come up with. Now, part of the problem is, what do we define as gravel? That's usually material brought in because there's already the existing subgrade, but this is the material you bring on top of it. Over time, most gravel roads are probably going to be closer to 12 to 18 around New York State that we've seen. Though sometimes people will go thicker, and I know of places in the state where they can't pave the roads for a variety of reasons. Sometimes it's because they think the roads are more scenic if they're unpaved. That's a discussion for another webinar maybe that we could have. Okay. So now all of this comes back to, we have to look at traffic too. So based upon those same answers you've been giving me, what kind of volume of traffic are we talking about in the course of the day? Okay. Closest 100, by the way, don't go putting in some weird number. Closest 100, 200, 300, 400, things like that. Give me nice, simple numbers. Okay. Let's see what you guys come up with. The most common vehicles per day when you're thinking about the traffic on your roadway. Somebody put 1,200, by the way. 2,000, okay. 6,000. Okay. And we got a 5,000 sitting over in the Q&A. 10K, which is the same as 10,000. Okay. So I want you to notice the variety here. One of the things we've traditionally not done very well is modify that structural thickness to account for the change in traffic. Now, it's not a linear relationship, and we don't have time to get into that today, but I want you to realize that we really should change the thickness to account for these variations. I'm certainly going to have a very different structure if I'm dealing with 5 to 800 versus if I'm dealing with 10 to 15,000. Okay, so there's going to be a variation in thickness. Now, if you're interested in doing a little bit more, we do have a tool for doing this for low volume roads under 2,000 vehicles a day. We call it the RoadP LHI, which stands for low volume highway inputs or infrastructure if you prefer. And it's a tool that's available on our site. It's in the handout. You don't have to write anything down. In fact, you're all thinking the same thing right now because this is a screenshot of the spreadsheet that we're using. You're saying the figure's too small. Don't try to read it. If you're interested, you download and try the tool. And again, it's in the handout that's available in the chat pod. Okay. Now, to do this with any pavement design, and by the way, this works for bridges as well, you first got to check the existing structure. We don't always think about that, but you got to check the existing structure because you probably used up some of the life. You then run a design calculation, and when you get done with that, you tweak it a little bit. And how long does it take? Well, we could probably make it faster. We found it takes about the time for you to grab a cup of coffee and get it ready to go and start sipping. Okay, so it's not a long process to do the design, but we don't do a lot of design. We use a lot of catalogs. And the other thing we don't tend to focus on is the quality of the gravel underneath. And so I've been laying a lot of groundwork here because I really want you to understand how important it is to have a good gravel. The gravel that you've got underneath, whether it's your base or sub-base layer, makes a huge difference in the structure. Okay? It can reduce the amount of asphalt you need for the same amount of traffic by a factor of 2. And, you know, the price of asphalt is certainly not low right now. So I'd rather spend my money on the gravel than I would spend it on the quality of the asphalt. Okay, so what's a recipe for good gravel? Well, obviously, someone's already mentioned it in the Q&A. We got to have drainage. Absolutely got to have drainage. Under drains, good drainage on the side, subsurface drains, keep the water away, drain it. You got to have the right mix of your gravel. And of course, you got to do a little bit of testing. Okay, so let's talk about that. So what's in that good gravel recipe? Well, it needs to be clean, which means We don't want too many silt and clay particles in it. We'll talk about the numbers that we have found over the years that work for us here in New York State. You want those materials to be strong and not break down in the traffic or polish. They need to be durable and not have problems with freezing and thawing. That's why we don't typically use shale when we're building our roadways. Shale is not a good material, and yet we have a lot of it in New York. It's good for holding gas deep under the surface, not good for a gravel road. It needs to have the right gradation, well graded, okay? The right mixture of the small particles, the medium-sized particles, the large particles. And we really want it to be non-plastic. The closer it is to non-plastic, in other words, the closer it is to not having any clay or clay-like particles, and we'll talk about that in just a minute, the better off you're going to be. And if you're dealing with near the surface, you'd like it to be angular. Now, if you ask me, of all of these, which one's the least important, depends where it is in the roadway. If you have a gravel roadway, that angular goes up towards the top. You need those crushed faces to interlock, to lock the things together. If you had all rounded stone, it wouldn't hold up. If, on the other hand, it's a base gravel under an asphalt, I'll give up the angular to get something that's non-plastic and clean. So you need to prioritize what's important. So let's look at each of these a little bit. In terms of clean, that means we don't want too many fines. And fines are silts and clays. Now, we did a study. I didn't do it. I wasn't around. In fact, when it got started, I wasn't around at all. I was a thought, maybe, to somebody, I hope. But the idea was we got gravel samples from every county in New York State. We looked at those gravel samples and we said, what makes good gravel? What makes bad gravel? And by the way, New York State is mostly glacial till. And we found that we need about 50 to 70% gravel-sized particles. These are the particles that are, bigger than a quarter inch, less than 3 inches. We don't want two super-sized particles in there because they don't lock well, don't hold up well. We need 50 to 70% because that's where the strength comes from. Okay, and that's true whether you're in Long Island or all the way up to Buffalo or up in the North Country. We need 25 to 40% sand. Okay, that helps fill in the voids. It's still pretty good for draining the water out. Pretty good stuff. In fact, one of the problems you see in parts of the state is we can't get enough gravel. That's actually a problem on Long Island. They have too much sand, and you may have to modify things a little bit and deal with that. And then we found that if it's underneath the surface, we need about 0 to 8% of those fines. Anything above 8% is going to create problems. 8 to 15% for the surface because the fines become your binder. Now, this is what we found in New York. I'm not saying this is the only gradation that would work for you, okay? And we actually have a whole series of tip sheets on gravel that you might want to look through later on. They're linked in the handout. We also have a link in there to a set of standards from Pennsylvania, from the Dirt and Gravel Roads group down there. You might want to compare them. There's some pretty good stuff in their aggregate, and they're actually surprisingly similar if you really look at them carefully, okay? Now, if we do this graphically, it's sometimes easier to see. You can see where this fits. In all the mixtures we can come up with, we really want to have clean material, low fines content, a little bit more on our gravel surface, good bit of gravel, moderate amount of sand, okay? So what do you have available in your area may make a big difference, okay? So this is what we want. This is what we'd like to see for a paved roadway. We'd really like to see a nice, smooth, in this case, it's a thin cold mix with a chip seal on it, okay? Holds up just fine, got a good gravel underneath, should be in good shape. But here's the thing. Most roads started as gravel roads. Even roads that are now state roads started as gravel roads. And if you take that gravel road and you cover it over, you take a material that was probably, just because of history, in that hash zone. It probably already had 8 to 15% silt and clay. And now we cover it over. And the water that used to evaporate, because there's going to be more water in it because it's got more fines, that water that used to evaporate blows that chip seal or that surface apart. And this is what happens. This is a roadway that had about a 13% fines content, okay? It was really a pretty good gravel. We actually went out there and we helped them out. And we did a test while we were there, came back to the lab, and it was 13%. Let's see, do I like that color? No, I don't like that color at all. Let me change colors. Come on, mouse. Where'd you go? Some days the bear bites you, some days you bite the bear. There we go. Try that again. Yeah, 13%. So 13% fines, which again, we go back and look at our gravel mixture. It turns out it was right in the middle of the zone here. Okay. So good surface material, not a good base, and it blew itself apart. Okay. And if you're wondering, by the way, why that 8% line on the fines content has to do with the weather around here. What we found the hard way was that above about 8%, the materials start to become prone to frost heave if they're mostly silts, which, by the way, most in New York State is mostly silts. And even the clays around here aren't the heaviest clays in the world. And so we get something like this. You get a fines content that's too high, it'll move on you in the winter, and you'll have problems. You find every culvert the hard way, because I bet they didn't pave it that way. Okay. We really think the line probably was straight when it was put down, but sure enough, we got a frost heaving problem. So that's why we want to have low fines content. Makes a better gravel, drains better, lasts longer, and of course, it's actually stronger as well. Okay. Now, how often do you test your gravel? Do you test your gravel never? Do you do it once a year? Do you do it as things change? Do you do it for each job? Or do you only buy from a state-approved gravel pit? You always are buying from a state-approved gravel pit. What do you do? Okay, let's see what people say. Okay. So most of you are trying to buy from state-approved plants. That's good. Okay. And once a year could work. Actually, I'm not totally upset by doing once a year, but you should be able to figure out when things change if you're only doing it once a year. And I'll talk about ways to do that that don't cost a lot of money. Okay. And as for testing each job, realize that gravels change. Gravels from a gravel pit are notorious for changing. They can change really quickly. There's 3 gravel pits out near where our former director, Lynn Irwin, used to live. There's a town pit, a county pit, and a private pit. The private pit is still running. They've still got good gravel, really clean stuff, about 5% fines, really nice stuff. The town pit right across the street, too many fines. A lot of silt, can't use it anymore. The county one, even more. So it can vary very quickly within a site, especially because you've got these glacial materials that got deposited and they can vary. So I would say on this list, think about coming up with ways to when things change, going back and doing another test, because tests are cheap. Okay. And we'll talk about those tests. They are really good insurance, or as a motto from an old concrete testing company used to say, one test is worth 1,000 expert opinions. Okay. So what test do I recommend? Well, obviously we need to do a sieve test or grain size analysis. That means you figure out how many gravel size particles, how many sand size particles, how many silt and clay. The biggest thing on those tests is you have to do what you see in the photograph. You have to wash the fines off to get the fines content right. If you just shake everything into the sieves, you're going to get a poor number, because those fine particles will hold on to the bigger particles and you can be fooled. We've seen examples where when they didn't wash it, the fines content looked like it was under 5%. When you did wash it, it was over 13. That's a huge difference. That goes from being an excellent material to really not being good at all for a base. So you have to do the wash. Make sure if you're having somebody do it, that they do the washing part of it. We recommend you do a soundness test. It's a minimum once a year. The soundness test is something we'll talk about a little bit more, but it's an important test to determine how it's going to handle freezing and thawing. Does it break down? That's why we don't use shale and a lot of the materials in the Catskills that just don't hold up to the winters around here. We need to do the plasticity or the plastic index test to determine how plastic it is. And I'm going to give you an alternative test we think is actually more useful here in New York State called the sand equivalent. And I'll talk about that in a little bit more detail. Now, soundness. Remember, I said freezing and thawing. And we have a lot of shale around here, and we have some beautiful gorges because of it, but they break down when they freeze and thaw. Ice crystals get formed, and it breaks the particles apart. So how do we do soundness? Well, we could use water, but we don't. What we use is magnesium sulfate. Now, you probably know it by another name, Epsom salts. What we really do is we take a saturated bath of Epsom salts and we stick not our feet, but we stick the rocks in, take them out, heat them up, crystals form. And we do this for several cycles, 4 to 10, depending on the application. And again, if you've got more details you'd like to read about, go open up the gravel deeper digs that are listed in the handout, and you can read more details about how to do the magnesium sulfate test and why that's an important test to do. But it tells you whether it can handle the freezing and the thawing. Okay, now there's some other tests we also could do, but that's one that's really critical around here. We want to do the plasticity index. And this is one that for those of us who went to college, we did these tests once or twice in school, where we take a little pad of material and we do a groove in it, and we hit this little cup, and it causes that groove to come together, and that tells you something about how liquid the material is. And then we make little snakes that are a 1/8 inch diameter, and that tells us how plastic it is, and the difference between the two we call the plastic index. Sounds great, but if you've got a dominant silty material, which again, most of New York is dominated by silts, you can get plasticities under 7 or 8. Once you get below 7 or 8, it's really hard to tell sometimes these materials apart. It's not a very sensitive test. And so if you're in Texas, and none of you were, if you're in Texas or Montana, absolutely. Plasticity index is the right way to go. But here in New York, we actually think the sand equivalent is a better test. And the concept of this is you take the material, you shake it up in a solution that causes the materials to settle out, a flocculating solution, and you let it settle. And you look at the ratio between the height of the column that settles, stays in suspension, those are the clay-like things, and very fine silts behave clay-like in the presence of water, versus the part that will support weight. And it's all timed and stuff like that. And so, for instance, here's the end of the test. Okay, the timer hit 0, and you can see the material has settled down from 15 inches down to just below 8. And there's a portion out the bottom you can actually see that's mostly sand-sized particles. And the way we really look at this is we put a weight on it, and we measure the height of the column that can support weight. Now, if this material were completely sand, the ratio between those two numbers would be all sand, it'd be 100%. If it was all clay or silt-like materials, it would be 0. Now, real-world materials don't behave that well, but we'll look at this in a different way. We do a clay reading first, we put the weight on it, and we get a ratio. We call that the sand equivalent. Okay. And again, very sensitive. We've seen materials here in New York State that are non-plastic. So they would meet the plasticity requirement for anybody. But in one case, the sand equivalent was 6. This is a material that's really not very good for using as a base, because it's going to really have problems with freezing and thawing and holding up in the winter, versus another one where the sand equivalent reading was over 60. And the reason it was over 60, it was mostly heavier silts that actually could support some weight to it. Okay, so we think this is a more sensitive test. So let's look at these materials we did in this test. And in this particular case, the clay number was 7.7. The sand number was 3.2 once we put the weight on it. So what's the sand equivalent in this case? So I'm going to make you actually do some math. What's the sand equivalent in this particular case? Get my pen going here. If anybody's brave enough to throw it in the Q&A before I do the calculation real quick. It's making us do calculations. Get out your cell phone. That's where calculators live these days. 0.41 or 41%. Yeah. It turns out if you do the math, the clay number is, we do the sand number over the clay number, which is 3.2 over 7.7. And it's actually, we always round up. Again, this is just one of those things you learn. The standard always rounds up. So it actually is 42. but 41, 42, close enough. The point is, this is actually a pretty good material. It's not perfect. It's not the 60 that's great stuff, but it's pretty good stuff. Okay. In fact, they used a sand equivalent. In fact, it used to be in the standard for super paved asphalt mixtures for the sands to make sure that the sands could hold on. It's actually still a pretty useful test. The cool thing I like about it, I can do it in the field. I can do it in the field in about 45 minutes. So it's something you might want to think about putting into your standards, and it is actually part of a standard that's in the state specifications. It's state standard 667. We'll talk about that in just a second. Okay. So what we found was that for base selection, remember this is the base of our roadway, it's going to change where we want to be. So if I'm looking at a base, I would like to have very few fines, 0 to 5%. I don't want frost issues. And I want that sand equivalent to be greater than 40 to make sure that it's going to stay strong when it is wet in the spring. Now you could use a plasticity number. Something less than 5 is a typical number you'll see, though I have seen specs that say non-plastic as well. But again, they're not very sensitive. Anytime you get a plasticity under 10, I do worry about the sensitivity of them, to say the least. And on the other hand, if you do sand equivalent, you can also use it for the surface as well. The sand equivalent has to be at least 25, but you don't want it too great. You actually want a little bit of that characteristic of a clay to it. And by the way, this is part of the reason that we can't mix surfaces in base. Not only the fines contents need to be different, but the sand equivalent numbers need to be different as well. And if we're really specifying, we need to look at both numbers. Now, we did work with the state. It's in the state standards. And yes, I know it's an old paper one. Nobody does paper anymore, but you know, I like old paper sometimes. And standards section 667 has in it 3 surface types: a surface, a base, and a subbase for your gravel. And it's something you might want to think about to improve the quality of the gravels you use for your roadway. Okay. Versus, I'm going to ask you to raise your hand. How many of you have purchased or used or specified item 4 gravel? Raise your hand. You've specified, used, or purchased item 4 gravel. And again, I'm just looking at numbers. I won't look at your names, I promise. I'm just looking at the number. So we have at least 4 honest people here. A lot of us have dealt with or purchased something called item 4 gravel. Item 4 gravel sounds great. I knew I was forgetting something when I got in today. I can't see my book right now. Item 4 gravel has not been a state standard since 1972. Now we still have a thing called type 4 in the gravel subbase series, but that material, if you look at it carefully, is a subbase for state highways. It's not a base gravel, because remember, the state uses asphalt bound for their base. They don't use unbound materials. So if you're doing a subbase, we can get away with a little bit dirtier material, but if it's a base or a surface, you need better quality material. So it's something you may want to think about to improve your roadway, because it's a lot cheaper to buy good gravel than it is to buy asphalt. Now, I did say I really want you to do additional tests when something changes. And the way you can do that I find most effective, is to do a series of hand tests. Learn those hand tests, and it can tell you when something changes. So you've got a testing point, you know, you've got good gravel, you've done the hand test. Your hand's very good at seeing when it's changed. It can't tell you what the starting point is. You know, you think moisture content is 10%. Well, that initial starting point, you don't really know. But those tests are pretty good. First one, take the material and put it in your hand and just rub it on your fingers. And should have about the same level of cleanliness. You should have pretty clean hands when you're done. Hit it with a hammer. Take the material, put it make a little ball out of it, about 1 inch in diameter, put it on a sill, sit it in overnight, and hit it with a hammer. If it's got a lot of clay in it, it's actually going to fracture into little chunks. If it's got a lot of silt, it's going to tend to powder on you and just go poof. And by the way, the rocks, you can hit the rocks as well. If the rocks break down under a light hammer tap with a small 2-pound sledge, probably shales or conglomerates, things that don't hold up too well. So a good hammer test can be very helpful. Make a snake like I'm doing in the photograph. Okay, this is sort of the field version of the plasticity test. And if you can't make a snake, means it's probably non-plastic, which actually is good. And if it starts to suddenly make a snake when it hasn't before, maybe you got to think differently about it. Take the material, put it in your hand, get it saturated so that there's extra water. Scrape the surface to get a nice dry sort of looking surface and hit your hand on it. If the water comes to the surface, you've got silt. If it doesn't, you've got clay. Now, of course, you can be fooled a little bit, but it's surprisingly effective. And it does tell you when something has changed. And then, of course, the dry strength, that same material you hit with a hammer, you can also sometimes just squeeze it with your hand, okay? So learn those hand tests. They can tell you something has changed, and then you go out doing those series of tests. Now, in the Q&A, can somebody tell me how much money you're spending to do your test, your SIB test right now? How much does a SIB test cost? How much does a SIB test cost? State doesn't. There's still a cost. Remember, there's always a cost to anything. So I'm always a fan, even if someone else is doing it, what is the actual cost? What is the state spending? Some people say $300 per sample. The last time I checked with the folks at one of the testing firms, not collecting it, just doing the test itself was in the $100 to $150 range if you got them the materials. So again, you might want to think about what it costs and a cheap insurance. And of course, talk to the people around. We know where the good pits are. Everybody has a good sense of what makes a good gravel. But what do? We don't have a good gravel. We know it's harder and harder to get a good gravel. Or if you got an existing roadway that, it's not holding up as well as we'd like. How do we get things into that blue zone if we need them in that blue zone for a paved roadway or even the unpaved roadway? Well, you've probably all heard the term full depth reclamation, or FDR. Not this FDR, it's a different FDR. FDR, or full depth reclamation, is one of the many asphalt repair options that we have available to us. Okay? It's more than recycling, which is just the surface. It's reclaiming and using that base and making it closer into that blue zone. And by the way, when it comes to repair options, my favorite is the one we're doing right now, which is nothing, because it's easy and it's cheap. And it works on your good and bad roads as well. So when you're thinking of repairs, try to do nothing. A brand new road doesn't need anything, and a road that's really in bad shape, it doesn't need anything either until you're ready to actually do it right. And of course, can't do a session without talking about drainage. The only three things that matter in a roadway, in fact, are the drainage. So take care of the drainage. Otherwise, you can do what our friend Mr. Jay Olson did with his photograph. Drainage is critical for roadway design. Ducts are an indicator of poor drainage. Now, total reconstruction is very expensive. And while it's sometimes the only option, and you do get a brand new roadway when you're done, it's very expensive. So it's something that sort of think of as a last resort. I mean, we don't even do that much of it. If you think about it, if you're doing 1 mile of reconstruction a year and you got a 100-mile roadway, 100 miles of roadway you're dealing with, that's a 100-year cycle. So it's an expensive way to go. So you might want to look at different alternatives. Though, if you're doing all the utility work, maybe it's a good time to do a total reconstruction. And by the way, this is for another webinar on safety. We should spend the whole afternoon talking about the safety issues here. So let's talk a little bit about reclamation and stabilization. You almost have a new road because you're repairing the base. You're actually taking advantage of the base material that's not quite where you want it to be. And it's a very cost-effective technique. But the keys to make this work: first, you've got to pick good candidates. Not every candidate is a good candidate. You've got to improve the drainage, and you've got to choose the correct additive. That's absolutely key. There's lots of additives that you could choose, okay? And the reason we can do reclamation is because, and the reason we need to do it, is a lot of our roads have evolved over the years. This is in the town of Pavilion. This road is paved today, okay? But it originally started as gravel, as most roads did. And so it had probably more fines in it than we'd really like to have. It probably doesn't hold up too well. But you got to have good candidate selection. Now, when it comes to surface repairs, we're pretty good at it, okay? If I've got a roadway that I'm looking at doing crack repairs, I can pretty much tell good candidate selection, as in this is not a good candidate. But it can be a little bit harder when it comes to what's a good candidate for full depth reclamation. Okay, is this a good candidate? We don't know, because we don't know the quality of the material and how it's going to match up with the stabilizer. And of course, it may vary across the width of the roadway. So you really have to sample what's going to be the blend after you've taken everything out and blended it all up. So we're a big fan of not just a small hole, but test pits. So you can see the difference across the roadway. You can get good quality samples. You get plenty of materials. And so, you know, I'm a big fan of test pits. I've been doing them since my hair was a different color than it is now. And it also tells you the thickness, which helps you with the design. And remember, our goal at the end of this process is we want to be in, if it's paved road, in that blue zone, if it's unpaved, in the hatch zone. Okay. So what could we do? Well, we could just take the roadway and pulverize it. Just blend it right back into itself and be done with it. If you've got a moderately good base, unpaved, unbound base, and some asphalt on top, which is old, you blend the two together, you might actually have a pretty good base when you're done. You could do what is technically called mechanical stabilization. What that really means is, I'm going to bring in some extra rocks that are nice and clean. I'm going to blend them with everything I've already got. And when I'm done, I'll have the right mixture. So if I go back real quick to my chart, I take a material that is, oh, maybe it's a little bit too dirty. Okay. I take material that's a little bit too dirty. It doesn't have quite enough gravel in. Maybe it's up here. Okay. You're going to write for me? There you go. And I get some really good gravel that has almost no fines, maybe not even all gravel, a little bit of sand. And anything that's on the line connecting these 2 points, I can make by picking the right blend. Okay. So I could make this by picking a point on the line and get the ratio right, 50 to 60% in this particular case. And I'm in the blue zone. Okay. So that's all mechanical stabilization means, to be honest. You can add chemicals. Calcium chloride is probably the most common chemical that we see. That's good for frost, and especially on lower volume roadways. Economically, it can be good. You could add cement, which is relatively expensive, but has a really broad range of capabilities. The big thing with cement, don't add too much. It's true with any stabilizer, actually. You could use fine fly ash. Be careful around here because you got to have enough clay for it to react. You're adding essentially silt when you add the fly ash in. And if it doesn't react properly, you've just added silt, which again, it's fines, and that may not work for you as well. We see a lot of bituminous stabilization here in New York, both straight emulsion or foamed asphalt, and that changes how much you can get away with in terms of the amount of fines that you can treat. Because remember, you're going to bind those fines up with the asphalt so that the gravel-sized particles, the sand-sized particles, are the ones that are doing the work then. Okay, and the negative effects of the fines don't get in the way. You can always do a combination. In fact, a lot of the bituminous stabilization, they actually do add cement in small amounts to help dry it up, make it get on the road faster. So here's a demo we did at the highway school for cement stabilization. In fact, there's Len Irwin right there. It's near where he used to live. Okay, very proud of this work. But here's what happened. They did 2 days of work. The first day, they had the perfect amount of cement to add to the mix. Second day, they had a little extra cement on the truck. They didn't want to drive it back. So they went ahead and they put it in the roadway. Sounds good, right? The problem is if you have too much cement, it makes it too brittle and it begins to crack. And the line that you can see, okay, and there's a line right here. See this line right here, right above where I just drew the line, that little black line you see? That's not a shadow, that's a crack. You add too much cement, can make it brittle. So don't add too much, whatever you're adding. Get the right amount and go down the middle. And then you're going to blend it all together. And again, if we had 2 hours, we could talk a lot more about this, but it's a really good technique. And the goal, of course, at the end of the day, is to try to get our fines content by binding the fines up into the right range, depending on what it's going to be in the roadway, the surface, the base, or the sub-base. We want the sand equivalent when it's all blended together to be in the right range. Okay, and by adding these things, we improve the sand equivalent, we improve the plasticity because we bind up the negative things with the different chemicals. And so how do we do this? Well, we've done projects over the years, And here's what we found. If we look at the fines content, and it's in your handout, so I'm just going to show you what you've already got in your handout. We'll talk about it a little bit. If the fines content is 0 to 10%, typically on the higher end, of course, because if it's in the lower end, you probably already have pretty good stuff, unless it just doesn't have enough gravel, like maybe you're out on Long Island and it's all sand. In this case, adding aggregate or pulverizing what's already there and blending in the asphalt is usually enough. But you should check to make sure the existing material has a sand equivalent over about 35. It's really pretty much, we just want to get rid of lower the fines content and get into that blue range, get it where we want it to be. And if you prefer, you could use the PI under 5. But again, PI under 5, I could get 6 operators to give me a result for the PI under 5, and I'll get 7 different answers. So just be aware of that. Now, if you want to use asphalt emulsion, this works pretty well from about 8 to 14%. So you got roads that have been pretty good gravel surfaces. And instead of just chip sealing them, you can actually just blend in asphalt emulsion before you pave it. Or you get a roadway that breaks apart every spring and you test it. It's got a fines content that's a little high. Asphalt emulsions can work really well. But as a minimum, the sand equivalent needs to be at least 25, so that when you're done, you brought that up into the 35, 40 range where you'd like it to be. And again, you could look at the PI, but we prefer the sand equivalent. Now, you could do foamed asphalt. The idea behind foamed asphalt is goes back to elementary school, and you had that milk and you blew your straw into it and made bubbles. It's the same concept. You make these bubbles of the asphalt, and it helps coat the stones. And you can get away with a higher range. Now, we did 14 to 20%, sort of this delineate between the two. But the reality is, you could probably use foamed asphalt a little bit lower than 14%. Depending on what the sand equivalent number is. If you had a sand equivalent of 35, you could probably use foamed asphalt in most cases. 30 is the minimum we found, but higher, of course, would be better. Because remember, we want to be above about 40 when we're all said and done. In this case, you definitely want it to be non-plastic. If there's any plasticity at all, you really want to be careful about that. But again, look for a good sand equivalence. Now, calcium chloride works really well when the sand equivalent is above about 30. But remember, all you're doing here is reducing the frost susceptibility. You're not changing the fines content. You have the same fines when you're done. And so for low volume roads, calcium chloride is a very effective technique. It reduces the period of freeze thaw on a mainline roadway, collector, or an arterial. Calcium chloride may not be enough. You might want to look at something more. The asphalts, the aggregates, or even the cement. Not as many notes with the cement, except of course the economics. There's some cost involved. So really be aware of the cost involved when you're thinking about using cement. And then of course, lime fly ash. You got to make sure your PI actually is above 10, at least 11, preferably higher. So just something that you want to keep that in mind. You're thinking about lime fly ash. It's something that you want to keep in mind. Now, do me a favor, raise your hand. How many of you have done asphalt emulsion stabilization? Raise your hand. Let's see how many of you have done it. Okay, so a few of you. Okay, now watch this magic. Watch this. Everybody's going to have their hands lowered. Jody and Amanda, lower their hands. Okay. Now I'm going to ask you, how many of you have done foamed asphalt? A different technique. Let's see how many have done foamed asphalt. Nobody. It's a technique you might want to think about. It's actually a pretty cool technique. Okay. How many have you done cement? Got a couple cements. Okay, one cement. Okay, and then finally, calcium. How many have done calcium? I expect a few more, but we'll see if I'm right. 2, only a couple of them. Okay. It is something I would think you want to add to your bag of tricks. I will admit, in an urban area, a lot of utilities, these stabilization techniques can be harder to do. They can be done, but a lot of times in an urban area, what they'll do is they'll carefully remove the material, stockpile it, blend it, add a site, and put it back down. Of course, when you do that, the timing can be challenging for the emulsions and the cements. So it's something to be aware of. Okay, so let's ask a few questions to give us our PDH and just as a test to see how we're doing, and then we'll get you out of here. So a good gravel surface makes a good gravel base. Is that true or is that false? That's a cute poll. And again, can't answer it. You can always. Good gravel surface makes a good gravel base. You're thinking about it, I can see. But remember, we've had a lot, our roads all started as gravel. You need fines in a gravel roadway. That's your binder. That's what holds it together. So a good gravel surface does not make a good gravel base, because this is what it can lead to. Again, this was a road that had been gravel for 30 years or longer, probably. And they chip sealed it, and it failed them almost immediately because now the water that used to evaporate blew the roadway apart. So we really need to be careful as we're taking a road and paving it that was gravel to clean up those fines, lower the fines content. And by the way, there are places in the country where they depave, they go back to gravel. They have to be aware of the fact that you actually need to add back in some fines, some filtered clay to help hold it together, because now it will be too dusty otherwise or gravel. Alternative to the plastic. Oh, I should change that. If the plastic index test, not the plasticity index, a plastic index test. Okay. What's an alternative? See what you guys come up with. Is it sand equivalent or SE? It's usually called sand equivalent. Yep. Okay. A relatively inexpensive test could be done in the field. You can have a traveling kit. If you're ever interested, I could even do the test for you at one of your county meetings. Just let me know. What a fun to do. Testing your own material. Okay, so the sand equivalent is a pretty cool test. We actually recommend it, especially here in New York, where we have relatively low fines most of the time, but low plasticity most of the time. An FDR stabilizer can be chosen from surface analysis only. I can choose which stabilizer I need from just looking at the surface. Yeah, very good. Nice job. Yeah. I can do crack repair decisions. I can decide whether or not an overlay might work or not and get pretty close. But if I'm trying to decide what I'm going to use for a stabilizer, I absolutely have to do a test pit, do a core, get underneath and see what's down there. Now, if you got good as-built, maybe, but things do change. When we've seen tests done by others, materials that were put down, we know were clean, over time have broken down and are now dirty because they did, they had a little bit too much silt or shale or something that broke down over time. Okay. So very good. Nice job. Something to think about. The quality of the gravel underneath is going to drive a lot of things. Now, we hope to see you on Thursday for communications. Next week, we're talking about the MUTCD, and then we'll have one more webinar to finish our summer series on snow and ice on September 10th. With that, I'm open to any questions. We got a couple of minutes here. I got 1 minute before the top of the hour. I'll let you go. If you have any questions, you can always email at clrp@cornell.edu or go on our website. You can just search for us by any means you want. NYSLTAP.org is the main address, but Google's pretty good. It'll find us no matter how you search. And with that, any questions? I don't see any questions. So we're going to say have yourself a great day and hopefully see you Thursday. Take care. Bye-bye.